Hi, this is Carl. We're excited to announce Microsoft's newest developer service called Azure Pipelines, a fully managed CI/CD platform for any app, language, or cloud. Azure Pipelines is integrated with GitHub through their CI marketplace and free for open source projects, with 10 concurrent jobs and unlimited build minutes for their cloud-hosted Linux, Mac OS, and Windows agents. Learn all the details by visiting azure.com/pipelines. Welcome back to .NET Rocks. I'm Carl Franklin.
And I'm Richard Campbell.
And we're in Sydney, Australia.
Indeed.
In front of a live studio audience. And we're gonna be talking to Joe here. And how are you, man?
I'm fine. Good to be down here again. It's the first time we've been together in Australia since, I think,
2009, right?
2009. So It's been a long time. It's great to be back together and making shows. And of course, we have this fun dynamic of we make a podcast, which is edited,
right?
But we're also live streaming it. So everybody watching, you're about to see the sausage being made.
That's right. So for the live stream people, you guys get to see our mistakes. But when we edit the .NET Rocks show, we'll take them out.
Yeah.
So
seamless, perfect.
Our editors make us sound smart.
Yeah, they're good.
They are
very,
good.
very good.
That's an astounding feat. Anyway, let's roll the crazy music for Better Know a Framework.
All right, buddy, what do you got?
I went looking to do an Alexa skill last week.
Oh.
And specifically for music to flow by.
Okay.
Because I was hanging out with Richard Morris down in Canberra, and he said, I'd really like to say, Alexa, play music to flow by, and have those tunes come on, or music to code by, because he's a coder.
Nice.
And so I was like, yeah, let's see if I could do that. It only took me a few hours. And the reason that it was so easy, Tim Hewer.
Tim Hewer?
Tim Hewer wrote a library called Alexa.net.
Oh, that's cool.
Yeah, Alexa.net is an abstraction that just it makes it so much easier to use Web API as your hosting environment for your skill.
Awesome.
So it literally took me a few hours, and I was able to get something that played and skipped and went to the next one and repeated, and even put in a little after the first three. Hey, if you really like this, think about subscribing.
Cool.
So thank you, Tim Hewer. It's Alexa.net, and if you want to learn about it, go to 1584.pwop.me.
Awesome.
That's what I got.
Good one.
Who's talking to us, man?
Grabbed a comment off of show 1557, the one we did with one John Alexander, who's here with us in Australia somewhere.
Yeah, he is.
With a broken wrist.
Ooh.
He had a fall.
Oh, no.
It happens.
Uncle
and that was
Owen.
a show we talked to. Yes, Uncle Owen has got a bad wing. That was a show we did back in June of 2018. We talked about ML.net. Right. And I know we're going to talk a little neural net today, so I thought this was relevant. And especially with your reference to music to code by, because Eric Stendahl said, have you ever tried playing music to code by to a neural net to get into the flow? I guess to get the neural net into the flow?
What?
I wonder if we could train a computer to produce unlimited music to code by tracks.
Oh, no.
That would be an interesting challenge.
Stop reading that.
It's an interesting idea. Like, if you played enough music to a neural net, would it play the music back to you?
Oh, I'm having fear of being automated into oblivion.
There you go. Eric is a regular listener. I've read comments from him before, and this was a hilarious one. So thank you, Eric. And a copy of Music to Code By is on its way to you. And if you'd like a copy of Music to Code By, write a comment on the website at .netrocks.com or via any of our social media, because we publish every show to Facebook and Google+. And if you comment there and we read it on the show, we'll send you a copy of Music to Code By.
Or you could just have your neural net simulator make it for you.
Make it for you.
That'd be good.
Save some time.
And definitely follow us on Twitter. I'm at Carl Franklin. He's at Rich Campbell. Send us a tweet. We add them to our playlist.
Okay.
That wasn't funny, but it was appropriate.
Yep.
Okay. And let's introduce our guest, Joe Albahari. He's an O'Reilly author and the inventor of LINQPad. Very good. Very cool. He's written 7 books on C# and LINQ, and including the upcoming C# 7.0 in a nutshell. He speaks regularly at conferences and user groups like this one, NDC Sydney, and has been a C# MVP for 9 years running. Welcome, Joe.
Welcome.
LINQPad is awesome.
Thank you.
Yeah,
Yes.
we're big fans, man. I can't believe you haven't been on the show before. Like, we should have been talking about that ages ago.
Yes, I believe I was here once before, and but yeah, we should be here more often.
So what does LINQPad and neural nets have to do with each other?
Well, LINQPad is a code scratch pad, and it really encourages experimentation and playing. And neural nets are great for experimentation and playing.
Mm-hmm.
So why wouldn't somebody make a console app versus use LINQPad? What's the benefit of doing that?
Benefit, you get immediate feedback with LINQPad. You get to see the results in a rich format. You got a dump method that takes just about anything and displays it nicely. And you got full auto completion as well.
Nice.
And tooling.
So it's a sort of an interpreter.
It actually does use the compiler, C# compiler, but it gives you an experience that's more like you'd get with a interpreted language.
Yeah.
Yeah, so that kind of line interactive, the way we used to program all the time, really.
That's right. Yeah, you just hit F5 and that's it. It's right there, and you can keep programming. And
yeah, I like to use it to practice lambdas because I'm notoriously bad at them. So that's a great way to just how does that work again? How am I going to figure this out? Yeah.
Which I think, was that the original intent of LINQPad? It was really
actually no. It was like almost like a pivot, because originally it was for really for writing, querying a database in LINQ instead of SQL. That was the primary use case, and it was just a nice bonus that you could also use it as a general purpose scratch pad for C# or F# or VB. But then that became the main use case.
It's just people tinkering with it. So we still get back to making a neural net. So is there libraries we need to introduce? I mean, I mentioned ML.NET from the comment. Is that something you use?
Well, the whole idea with the presentation I gave was that, there's nothing wrong with libraries. Libraries are the way to go if you need to get something done. The problem with the libraries is they're black boxes.
Right.
They hide it all away from you. So if you're really interested in understanding the fundamentals and the principles, the best way to go is to write something simple yourself. And that way you really get to know when something doesn't work or you break something, you learn a lot more than if you're just tinkering on your configuration and setup with some libraries.
That's cool.
And so how does one go about making a neural net from scratch? I mean, I know that's an open-ended question, but we might as well start somewhere.
If you've got nothing to start with, it is surprisingly difficult, because there are dozens of web pages and tutorials on how neural nets work and how a lot of people like to explain it in a way they think is simple. You can read through all that, start with an empty LINQPad query, and try to write one yourself, and you'll be amazed how what you write probably won't work. You won't be able to train it, and you realize you don't actually understand it.
Yeah, I think that pretty much wraps up and sort of encapsulates everything that my experience of trying to do those complex kinds of things. It's hard. Yeah.
Yes.
So where's the happy medium between using a library that's a black box and rolling your own? Where do you start?
You start rolling your own, I believe, if you're interested in understanding how it works. And once you got to the point where you've had a lot of fun with it and you understand how it works, and you've got actually a job you want to do, that's a good time to use a library. And then, all of those levers and knobs will mean something to you when you use it. And then when you change a knob and it doesn't work anymore, you'll kind of know why.
Right.
All of those things will be meaningful.
Is there like a quintessential set of data that you would use to start understanding this stuff, like stock prices or something?
Well, the data set that I've used for the demo, I've used two data sets. One is a very simple manufactured data set of ones and zeros in making a Nand Gate. That's one of the simplest things you can do. And you only need one neuron for that. You don't need a net. You can take one neuron, use a very simple activation function. You can train it to work as a NAND gate, and you can make that data yourself.
What is that?
A NAND gate, it's a simple logic gate. So if both of the inputs are 1, it outputs a 0, otherwise the other way around. So if they both are 0, the output is 1. If they're both 1, the output is 0. That's correct.
And what if one of them is 1 and the other is 0?
It's basically, it's think of an AND gate.
Right.
Think of an AND function, and then not it.
And not it.
Basically, yes.
So either both on it's off, 1 or none on, and it's on.
That's correct.
Okay.
Yes.
So it seems like a really simple thing to
seems
do
simple.
as a code exercise. I mean, that would be an easy function to write, for example. But how do you get from training data to an answer that's accurate?
Well, neural net has an inputs and a bias, actually. So in this case, a neuron would have two inputs. So you start off by setting those inputs and biases to small random numbers. So when you put the data in, it's going to give you the wrong result. It's going to give you you put the data in, you'll get rubbish out. But then you ask the question, what small change can I make to those inputs and bias to make it a little bit less likely to be wrong, to get a little bit closer to the right value? And you just keep repeating that over and over again. You keep more and more training samples through that, and it gradually adjusts the weights and biases till it gives you the right answer.
And in the case of this Nand Gate example, you were literally talking about a single neuron?
That's a single neuron. That's the example I use for a single neuron.
Right,
now,
you can't get simpler, really.
You can't get simpler than that. And when you can write that code, when you can understand that, then that's most of what you need to train a neural network.
So I thought a neuron, when we're talking about a brain model, there's two neurons together that fire in the synapse and all of that stuff. That's not necessary in order to...
The artificial neurons are inspired by the natural neurons in the brain, but they're not quite the same. Okay. So with an artificial neuron, it can work just on its own. You can have one neuron with inputs and an output, and you can train that on its own. And
is it just a binary state? Is that the whole idea?
You can choose. So depending on the activation function you use, it can either be have a binary state or it can have a continuous state. It can output real numbers.
Interesting.
And so what does the activation function look like? Are you writing in C#?
Yes, you write it in C#. The most popular activation function, I can tell you exactly what it is. If x is greater than 0, it's x. Otherwise, it's 0. Simple as that. All right, it's called a Aurelian.
That's the line of code that I was missing.
The activation functions that we tend to use nowadays are remarkably simple, and partly because for performance, because to get good results, say with large image training exercises, you need tens of thousands to millions of images, and the networks itself have thousands or more neurons. So the performance becomes an issue. They can take a long time to train. So they try to look for what is the most efficient, the simplest way that we can make these neurons that can work.
That's cool. So, I mean, I love the simple example. I got to think as it gets more complex, you kind of want to start from something. Like to me, this seems like almost a cut and paste operation. Like you'll have a few examples you can work from, and then you can tailor it. They're close to what you're trying to do and can help you tailor into it.
Yes, I mean, the next example I use is when we create a neural network, a two-layer network, is a popular database called the MNIST digits training database. So that's 50,000 handwritten digits with another 10,000 for testing. And that's very well publicized as to what over the decades that's remained constant. And so you can see the progress of neural networks and how well they've done with that and what kind of networks give you what results. So that's the one I use for the example. It's a very popular one, and it is quite good because it does something useful and real that you couldn't otherwise do.
It's a recognition.
Put a handwritten digit in there, and it tells you what it is, and it can do that with quite good accuracy.
Wow.
And like I said, we've been able to do this for many years, but it's a test case for it's getting simpler, easier. Like, can you train on fewer examples now? Like, what's gotten better?
Over the years, there's quite a number of things that have gotten better. You can use fewer examples, and one of the mechanisms that enables that is something called pre-training, where you, rather than starting off with an empty neural network, you start off with a network that's already been trained with possibly millions, let's say in the case of image recognition, it's been trained with millions of images, of general purpose images. So if that's a deep network with lots of layers, and that's been pre-trained, that can be your starting point for doing a new training exercise. You don't need as much data to make that work if you've got that pre-trained network.
Now, you mentioned sort of briefly playing with the training, just like a two-layer network. What about these sort of deep networks? How deep are we talking? Like, what does that look like today?
They can add literally nowadays dozens of layers into the networks because they're using different architectures like convolutional layers. And this is a work in progress. There's always new innovations in that, and they're coming up with cleverer and cleverer ways to make these deep networks trainable. So, I mean, because you can always create more layers very easily, that's not the problem. The problem is how do you train them? Because what tends to happen is when you add more layers is that the training doesn't converge. It kind of gets confused. You're making it almost too smart in a way.
Right.
Does that mean that there are use cases that lend themselves to neural networks better than others? I mean, because there's all kinds of machine learning other than
That's right.
neural networks.
Yes, neural networks is just one branch of machine learning, and there's other ones that I've not gone into that can also can work very well.
So are there things that, like recognition of handwriting and all that stuff is an obvious one, and prediction of data based on past data, trends and weather and those kinds of things.
Yes.
But can you give me an example of something that wouldn't work well with a neural network and maybe why?
I think some when you're looking for some patterns in data, if you're doing unsupervised learning, I think that's the case. But I don't know a lot about that, to be honest.
Yeah.
Unsupervised learning is when you don't have the answers.
The predictive analytics tends to be more the mathematical constructs than the neural net constructs. Like that, you could generally write predictions mathematically fairly well. You don't need to do training.
Well, I remember the big hot thing was stock prices, right? You download stock market data and add it to your neural network, and then it was supposedly able to pick stock winners. And, people went crazy over that stuff for a while. I don't know how accurate it was, but horse racing was another one.
Yeah. Yeah, I don't know which one of those actually make the most sense.
Yeah.
What's a good strategy? You mentioned convoluted network neural nets, and the other word that came to mind was Geoffrey Hinton's backpropagation. That was sort of the breakthrough a few years ago.
Backpropagation is just describes how you train almost any neural network. So it's the process of going from the correct answer and now looking at how it deviates the answer, output from the answer it should have output, and then looking at the errors and then the slopes of those loss functions and just making those changes propagate backwards. Because when you fire a network, it goes forwards from left to right, from the input to the output.
Yeah.
But when you want to train it, you start off with where it was wrong, and then you make adjustments from the output back towards the input neurons. So that propagation, that's what it describes, how you make those adjustments, and that's what we did in our example in the session. We went through that backpropagation.
So is that a bit of code you've written to backpropagate?
Yes, it's relatively simple code too.
So, I mean, I'm just fascinated with this idea of LINQPad and working in that space and sort of building up piece by piece. What does the trained neural net look like? Is this just a file? The trained
network is would represent the state of all of the neurons in the network, the long-term state. The state comprises the weights of all your interconnections plus the biases of all your neurons.
Okay. And sort of the value that it takes for it to propagate a value forward.
Yes.
Yeah.
And we're going to pause here just for a brief message that's very important.
Hi, this is Richard. The Dev Intersection Fall Show this year will be December 3rd to 6th in Las Vegas at the MGM Grand Hotel. The lineup is awesome. Scott Guthrie, Scott Hanselman, Scott Hunter, yes, all the Scotts. But also a ton of great industry speakers for some insight on what's coming up in the world of .NET. You know, Core 3 is bringing client technology like WinForms and WPF into play. Could it be time to migrate your existing desktop apps to this new technology? Come learn more at Dev Intersection, December 3rd to 6th in Las Vegas at the MGM Grand. Go to devintersection.com to register and use the code .NETROCKS to get a discount.
And we're back. It's .NET Rocks, Carl Franklin and Richard Campbell, and we're talking neural networks with Joe Albahari. And just sort of scratching the surface about how these things work, because I find that I don't understand how they work. And I think maybe our listeners might want a little more insight into what exactly, I mean, we have these things called neurons that have a state or they emit something and they have a bias associated with them. but how do they get smarter? Like, what exactly is going on down there? I can't visualize it conceptually.
It is quite tricky to visualize in the same way if you look at a fractal, like a Mandelbrot fractal, and you try to say, how is it that simple formula gives rise to this amazing complexity, this infinite level of complexity and beauty in that fractal? It is hard to get your head around how a simple mathematical formula can do that. Yeah. And I think there's some analogy there with neural networks, is that the algorithms that are used to train them are quite simple. The mechanisms aren't particularly complicated in the maths. If you're to look at it at a very granular level, they aren't particularly complex. They're just addition and multiplication, really, and division that we're doing.
Yeah.
So, but what happens is that you're building up a relatively complex combination of functions. So one function feeds into another, and that combination is quite then difficult to understand exactly as a whole and why it works. And if you really answer the question, I mean, an example is if a neural network, you train it with data and it all seems to be doing a good job. Then you put through a sample which seems to be reasonable and it gets it wrong. If you were to ask, why did it get it wrong? You can't look at this state and work it out just by looking at those weights and biases.
That's really interesting.
So you really have to just tell it, no, that was wrong. Try again, and something else happens? Or
you might have to do some experimentation on that to try other ones that are similar and think, could it be to do with the... It's quite tricky in that regard, and it will have interesting consequences as artificial intelligence becomes more pervasive in things like driverless cars, for instance. Yeah. If that uses neural networks or other machine learning algorithms and it has an accident, who do you blame? Well, you can't go to the programmer and say, look, your algorithm was wrong, there's a bug in there, because you won't find that bug if there's something subtly wrong in those weights and biases. It's learnt that. You can't blame it.
Okay.
As such, you can't blame the programmer.
I am getting a picture in my head, and tell me if this is in any way accurate or representative. I'm thinking of routing, right? Mm-hmm. And when you have 100,000 pipes, let's say, it's a series of tubes, pipes, and you have a ping pong ball, and you put it through one, and it needs to go back into another, sort of, routing. But you have with even 100, pipes, you've got just ridiculously exponential number of possible routes that things can go through. Is that really what we're talking about? Just like routing so that the answer is that comes in.
It's it's sort of the analogy sort of works, but I guess if you've got a ping pong ball, there's just one ball. Yeah. Whereas the idea with the nets is that you've got lots of inputs, and the idea some of them will get kind of switched off. Yeah. Some will get switched on, or some will be partially switched on as they go through and they combine with other ones.
Yeah.
If I tie back to your example about recognizing a number, in the end, the number itself is a set of values in a two-dimensional matrix that represent white versus black,
yes, correct.
And it grays in between.
Yeah.
And that you're literally feeding that array of values to the neurons.
That's correct.
And then they go through this triggering path to ultimately get you, that's a 9.
That's right.
Which, it's fascinating to think about it. There's a DARPA initiative called Explainable AI that I've been reading about, and their specific goal was to deal with this issue around neural nets. Right. I'm not so worried about blame when an automated car crashes. I think much more like the airline industry does, which is you don't worry about blame, you worry about understanding how it happened so that you can have it not happen again.
Yes.
And as long as neural nets remain unexplainable, we can't actually improve.
Yes. Well, yes, I can see where you're coming from. Right. Yes. Yeah.
So, I'm reading this stuff from DARPA around explainable AI, where their goal is not why did you get it wrong, but why did you get it right? Like, what did you see that had
and have they made progress?
That's a great question, right? And their theory, the way it was presented on the slide deck, which was lovely, was showing pictures of kittens and having the neural net say that's a kitten, but then being able to say, why is it a kitten? Because it has fur and claws and eyes, and that there's that concept of breaking it down. But I don't know that a neural net knows that.
The difficulty is if you look for those concepts such as fur and clause, then it is in theory quite possible that those are captured within those hidden layers, particularly their convolutional layers. But the problem is those things, they mean a lot to us, things like fur and clause. But it's quite likely that the neural net, the way it will have been trained, it will have very different concepts, if you were to call them concepts at all. They won't mean anything to us. We won't be able to really understand, or it won't look very meaningful, what those hidden layers are actually doing. They're probably not extracting claws or whiskers, right? They're doing something else that won't really mean much to us, and that's the problem. I mean, in order to get something that was meaningful to us, we would need to really have it share our kind of intelligence and all our knowledge and our background concepts.
Yeah, right. Yeah, it's one thing to recognize something, but it's another to apply all of the memories and understanding of the vast array of nouns we have stored in our think meat.
Yes, it's amazing it can do as well as it does when you really consider how little it knows.
Yeah.
Yeah. Well, and I guess, and I've certainly been reading where they're talking about, especially in these deep layers, that you can see that there's a point where it discards irrelevant material, that it's like, this is where it recognizes that's where the face is, and then goes to the next face of whose face.
Yes.
So there's bits where I'm thinking, well, maybe we can understand where these things go wrong and can be better. It's just an interesting it's interesting to me, this idea that halfway through the neural sequence, you could stop and say, what do you know now?
Yes.
Versus actually getting only to the answer.
So obviously there are tools that we're going to use once we know how our model works and we know how neural networks work. It's a little bit easier to understand how to use a tool and you use it appropriately. Where do you start with that? And I guess the options go all the way from, running something on your phone probably to the cloud.
Yes.
Yeah.
It depends on what problem you're trying to solve, really, on that, and it is a rapidly changing industry. So this changes from one year to the next.
Yeah, I think everybody's still very much experimenting. And I'm thinking back to the show we did was it Kevin Scott about the intelligent edge?
Oh yeah,
and just this idea that you may do this training, back at the lab, but the trained models can get deployed to edge devices, so that rather than sending the images back to your store, you're sending the analysis back to the store, moving a lot less data.
Yes, that makes sense.
How does parallelism come into play?
Well, it's very conducive to parallelism. Neural nets training and execution is conducive to parallelism. So there's two ways you can use your microprocessor to parallelize using the cores, or the way that most of the big libraries work is that they'll use the graphics processing units,
GPUs,
because these are they're very conducive to that, because you're performing these simple kind of computations that are similar to the computations that you perform when you're playing a 3D game.
Yeah, it's just that in 3D you're talking about reticulating splines, and here you would be backpropagating biases.
That's
right. Yeah. But either way, they're simple scalar math functions that are propagated across a lot of nodes.
Yes.
Easy for me to say.
Scaled across lots of nodes. That's the key right there. Little equation,
very wide,
parallel. Yeah. Well, hey, Richard.
Yeah, buddy.
Guess what time it is now?
It must be that happy time again.
Yeah, it's time to interrupt this talk on artificial intelligence and throw in a little natural stupidity.
Well, you do a good job of that, my friend.
Thank you.
Yeah, you
so
knocked
much.
that one out.
Yeah, thanks. I figured. That was an easy one.
There's plenty of...
That was a meatball, man. As I saw the topic, I'm like, boom.
All you got to do is reverse the terms, right? If it's going to be artificial intelligence, there must be artificial dumbness.
Natural dumbness.
There's certainly natural dumbness.
All right. Well, it's actually time to give away a $200 Amazon gift card, compliments of Progress Telerik, to one lucky member of the .NET Rocks fan club. But first, let me tell you about the most comprehensive developer toolkit for building modern apps on the market today, Telerik DevCraft. With more than 1,100 Telerik.NET and Kendo UI JavaScript components and controls, you can easily build modern, high-performant web, mobile, and desktop apps, as well as chatbots. The toolset also includes reporting solutions, automated testing and productivity tools, and comes with a range of support options. New this year is a free online training program for all license holders. alongside thousands of demos with source code, comprehensive docs, and a full assortment of Visual Studio templates, you'll be up and running with Progress, Telerik, and Kendo UI tools in no time. Download a free 30-day trial today at telerik.com/download.
Well, all right, buddy. Who's our winner?
Today's winner, Richard, is Jakob Sturk.
Congratulations, Jakob. No golf clap, real claps.
Real claps.
Real claps.
Yeah. And Jakob, who's also a Two Keto Dudes listener.
Oh,
also.
nice.
Shout out to Jakob. He says, I'm a huge fan. And I said, yeah, but you're getting smaller. Jakob won the $200 Amazon gift card from Progress Telerik just for being a member of the .NET Rocks fan club. And if you'd like to be a member of the fan club, go to .NETRocks.com, click on the big Get Free Stuff button, answer a few questions, and join the fan club. We have thousands of members all over the world. And every show, we like to give away stuff from our sponsors. And every December, we give away a $5,000 technology shopping spree to one lucky member of the fan club. But you got to sign up to win. We also like to ask our guests, Joe, if you had $5,000 to spend on technology today, what would you buy?
It's a good question.
Mm-hmm.
I think smart lighting would be good. The ability to paint your walls and colors and
The Philips
lighting.
Hue, the smart light
Yes.
bulbs that go any color.
Yes, or even
Nice.
ones that project something onto a wall, or that you can completely change your room with
Making
a
paint
smartphone.
obsolete.
Yes.
No, I love that. We certainly have a couple of hues floating around the great room in my place.
Yeah.
And Halloween, they're all orange and purple. And
Yeah.
yeah,
It's an interesting idea.
Well, and you can induce seizures really well because they will go to cycling different colors. It's like
Yeah.
look away.
Right. I like to, have my office all white and then have the color reflect my mood.
There you go.
So my wife knows whether to interrupt me or not.
The room is red. Just walk away.
Walk away.
I mean, the fun part is, $5,000. These Hue bulbs aren't that expensive. You'd have a house full of them.
You probably could, yes.
Yeah.
You'd get a lot with that.
And but they're all connected to Wi-Fi, so
Right.
you're going to need like a separate subnet in your network just for all your light bulbs.
So the fun part about that is going to Best Buy, which is, in America, that's where we go get electronics. One of the places anyway. And you go up for a specialized, Wi-Fi thing that doesn't need all the bells and whistles. And the guy's trying to upsell you on all this stuff. And look, I know what I'm buying. That's the one. I want the $60 version.
Right.
Because it's going to sit in a corner. It's going to have exactly 3 clients.
Yeah. That's all it's ever going to be.
Right.
True enough, I would probably, if you're going to get 100 Hues, I'd probably order them online.
Yeah.
Just saying.
Yeah.
Oh, well, let's dive back into this because I'm loving the idea. I really appreciate your position, Joe, on this learn it from scratch mindset because there's an awful lot of tooling and so forth. I think it's concealing a lot of what's really going on here. So you're literally just coding the pieces in LINQPad in front of everyone, or when you're presenting this, and then running those tests. Can you actually put that demo together, like the number recognition demo? It's got to be really compelling to show a graphic of a number and then see that this little neural net is get that number correct.
That's right. And there is a bit of I've pre-written most of the code because there's quite a lot of plumbing just to connect the neurons together and to draw to do the visualizations, to draw everything so you can see what's happening in real time. But the actual algorithm is something that's pretty. I can capture that pretty simply. The algorithm involved in firing and training.
Mm-hmm, mm-hmm.
Is it as simple as if X, then X, else X is 0?
Well, that's pretty much, that's the ReLU function, and it's that's one of them. We do some addition and some multiplication.
Okay.
And that's
some
pretty
heavy
much
lifting
it.
math, man.
I'm intrigued.
What
Anything you want to elaborate on there?
The training process for the network is really just the training process for each neuron. There's not a lot more to it than that. I mean, there's one tricky aspect of backpropagation, which is how do you get from from a layer of neurons when you're looking at the what I call the votes for change, which is really the gradient of the loss function. How do you propagate that backwards? But that is actually simple if you think about it in a certain way, which is that you're basically taking a weighted sum. You just make that weighted sum go backwards. And that's how you can.
And so you're taking like half of that sum against the first neuron, and then half it again for the next neuron.
You don't have to halve it. You could either add them all together,
Right.
Or you could take the average. Whether you add them or average them really doesn't make any difference, except that if you end up with bigger numbers, you might need to adjust your learning rate. That's the step size you take in proportion to the numbers.
So you have quite a few knobs to tweak to get the neural network to be more accurate. So is there a lot of that? Is there a lot of like, let's try this one. That didn't work. Tweak that.
Yes, there is. A lot of it, for instance, how do you come up with the optimum learning rate? That's the step size you take each time you make an adjustment. That is a lot of involves manual tweaking. Yes, and if you want to be quite sophisticated with that, you can automate that or write heuristics or even get the neural network itself to teach its own learning rate. But yes, there are quite a few knobs. But the minimum we need to get it working really is that we need a learning rate. We need an activation function for the neurons. And that's pretty much it.
So you were describing that
and
number.
And a loss function, obviously, which describes how the thing that we're trying to minimize. You've got to be very careful when you want to optimize that, because essentially the process is you keep making little changes to see whether you can make it better. But you have to be very careful how you define what is better.
Right.
Because the machine, we set the rules and the machine will follow them. It will do whatever we say.
So, I mean, isn't better as close to 100% accurate as possible? I'm sticking with the number recognition because I think it's real, but not too complex.
Yes. The problem with if we look at the using the accuracy as a measure, that's good right at the end. We can say, okay, this is how well we've done. But when we're making those small little increments, we don't have access. We don't know whether that's going to make one more test case work or not.
Yeah.
Right. So we need something that we can actually monitor as we're going along.
But isn't that turning up the training step? Is more likely that you move somebody into the win column that wasn't in the win column before?
Yes, you just need to know. You need to weight those training steps so that they're going to move the total loss or the total wrongness in the right direction, if you like. So, I mean, the simple answer to that is what we usually do is just take the square of the error, and that happens to work out very well as a loss function.
So the software that you wrote, is it fully functional to use in a variety of different use cases? And
yes, it's a general purpose network. It's not designed specifically for image processing.
Mm-hmm. And is it anything that obviously you're sharing it, right?
Yes, it's available on LINQPad. So you go to the samples and hit download more samples, and then you can. It's in the conference section.
I guess what I'm asking is there any problem too big that it couldn't solve?
Oh, absolutely. It is designed to be relatively simple. So it does quite a good job of the handwriting recognition for those digits. Yeah. Yes, of course, there are problems too big for it to solve. Yeah. I mean, I don't know how easy it will be to take that and turn that into something that can solve more elaborate problems. But I think there's a point where, you've got, once you've really used it for what it was designed for, like getting that understanding of how this thing works, it's probably time to move on to using a library for doing those kind of problems. Right.
But as Richard said, I really love the idea that, you can actually see the code working in a very simple way and step through it. Is it something that you step through, or are there so many iterations that
you can step through it? But there's a visualizer, so you can actually see the colors changing of the neurons as it trains.
Interesting.
Because it trains quite slowly. So you can actually watch the colors change as the biases and weights take form.
Wow. All right, now I'm completely intrigued.
I know that tone of your voice. If we were in our studios, you'd be typing right now. Like
I would. I'd be downloading it and just like
play with
look at the blinky lights. Yeah, very cool. So where can we get it?
If you download LINQPad and go to the samples, there's a link to download more samples in there. There's a set of built-in ones, and this is one of the extras. So if you scroll to the bottom of the extras list, there'll be a link for this conference session.
Nice.
Wow. What are your plans for it? Moving ahead.
I'm probably going to move on to something else.
Really? So what else is...
Did this start as a learning tool for you and you've decided to share it with others?
Yes. I mean, I was just very interested myself how they worked. Yeah. And I wanted to understand it properly.
Sure.
Now, why wouldn't we just stay with that? What what am I going to get now that I understand moving to an ML.NET or the cognitive services in Azure?
You'll get a whole lot of other machine learning models, and you also get other kinds of neural network layers, such as convolutional layers for image processing. You'll also get the ability to optimize and run it on graphics processing units.
Right.
And you'll have access to pre-trained models as well with some, millions of images.
Yeah, right.
Right.
And of course, cognitive services, you get all the models too, and just a high level, hey, what's this? Yeah, where you don't have to do any of that stuff.
But you are back to that black box effect. You don't really
Yeah.
know what's going on.
You can't tweak it.
Well, or you only get to tweak it the way the knobs they give you, as opposed to it was all your own code in LINQPad, and you can change anything you want to change.
I like.
You'll find a lot of the knobs are quite similar.
Right.
Once you understand the having written it yourself and made some mistakes, you'll find a lot of the stuff will make sense.
Can we talk a little bit about the whole overfitting effect? Like, can you demonstrate that?
I did demonstrate that in the demo. I demonstrated overfitting. So what I did was I improved I used a more powerful loss function on the final layer, and we ended up getting 99.9%. In fact, we could easily have got 100% accuracy on the training data, or very close to 100% accuracy on the training data. Now, what happened?
Can you just back up and tell us what overfitting is?
This will explain what overfitting is. So we got very good accuracy on the training data, but then when we tested it on another smaller set of data that it hadn't seen, it didn't do quite so well. It was only 98% instead of close to 100.
Right.
So what had happened was it had latched onto a lot of specific features of that training set, and it was unable to generalize those so well to data it hadn't seen. And that's what overfitting is.
Right.
It fits the training data too well, if anything, and then that doesn't translate to doing well with data it hasn't seen.
Your test data.
Yeah.
And so and if I remember correctly with this number set, it's like 10,000 that you train with and 50,000 that you can evaluate?
This is 50,000 that you train with, and then 10,000
that you test with.
And that's quite a common ratio.
Okay. You build with 5 times more data than you test with.
That's quite common to use that ratio, yes.
And then you are hoping that the percentage accuracy matches between the train set and the test set.
Yes, it'll never be quite as high, but you're hoping it's not too much lower. Overfit is simply a nice way of describing that phenomena, where it's quite a bit higher.
But I mean, I would feel like if you're doing 99 on the training set and 98 on the test set, I'm just not that unhappy. But
although actually we were getting close to 100.
Right.
So if you look at it the other way around, like what percentage did it get wrong? We're down to 1 in 1,000, right? If you got 99.9 something, you could have even been 1 in 10,000. So that's huge compared to the it does make the overfitting look more egregious.
Sure.
In that case,
I
but in the end,
as you get closer, you get worse results out of the test. As you get closer with the training results, you make the test results look worse.
They can actually happen, and that happened in our case because we actually, by putting that kind of exotic loss function in there, while we improved the training accuracy, we actually decreased the test accuracy slightly overusing the standard loss function in this particular case. Now, that won't always be the case, right? Your mileage will vary depending on the scenario.
Wow.
Do you find you could make multiple models, training on the same set with different sets of values, and get good results across a bunch of them? Or is there one right way, like with a given set?
No, there's no one right way because everything depends.
Right.
Right. So yes, you can repeat. You can try lots of different activation functions. You can tweak the high parameters in lots of different ways, and for your particular situation, that'll work well. It doesn't mean it'll work well in other scenarios.
Right.
And you also have to be a little bit careful when you start doing that because if you spend too long and coming up with too many different combinations, you might end up just happen to pick one that fits the test data.
Right. Yeah, that's what I was thinking. Now you're overfitted to the test data.
Now you need a third set called validation data, right? You keep another set you lock away called validation to know in the end how good you actually were.
But I mean, presuming you're building this number recognizer, now you put it out into the wild. are you still looking at its results routinely and sort of saying, is it actually maintaining that success rate that we hope for?
Well, this is a fixed set of data I'm using, so I've not tried it with any new data sets.
Right. Oh, well, realize it may with a third set of data not do near as well with either.
Yes. Given that I am comparing different models and different functions, it would be a good idea, yes, to have a validation set just to make sure that when I said, look, this activation function works the best, that it is actually consistent. That is a good point.
Mm-hmm.
So let's say somebody's using this to recognize their numbers and you get a positive recognition on it. Can those numbers then be added to your test data or to your training data? And so it just continuously keeps getting new samples of what are correct numbers?
Yes, that is the way that a lot of neural networks operate. So they do keep they keep track of if they've got labeled data, the data coming in is labeled so you know what the correct answer is.
Right.
Then you can keep using that to expand your training set.
Yeah, why not? So you were talking about moving on to the next thing, and I may have jumped the gun there, but what's the next thing for you?
Well, I think .NET Core is going to become quite big now, so that's going to mean LINQPad's going to have to move in that direction. So
sure,
being able to consume .NET Core.
Yes,
I presume you're depending on Roslyn for a lot of what you're doing inside of LINQPad.
Yes, that's correct.
Right. So
yes,
you're most of the way there then.
Yes, exactly. Because and I think .NET Framework is moving in the direction of .NET Core. So
sure,
the next version is going to be in
sort of a hybrid thing. Yeah. Well, that's great, man. Joe, thank you very much. This has been thrilling and enlightening, and I can't wait to download this stuff and play with it.
Thank you.
It's really cool.
Thanks. All right, we'll see you next time on .NET Rocks. .NET Rocks is brought to you by Franklin's Net and produced by PWOP Studios, a full-service audio, video, and post-production facility located physically in New London, Connecticut, and of course in the cloud. Online at pwop.com. Visit our website at dotnetrocks.com for RSS feeds, downloads, mobile apps, comments, and access to the full archives going back to show number 1, recorded in September 2002. And make sure you check out our sponsors. They keep us in business. Now go write some code. See you next time.
Got transmitter bands by the